Remember, like, from the 3rd grade where you learned to divide for the first time? We're going to go back to that moment just to remind you how to divide by hand the long way. And again, we do this to make parallels on what we're going to be doing today. So that first problem, and I apologize, this is going to take a lot of room, and in some of those spaces you don't have quite enough room. So if you're kind of prone to writing large, I'm going to cut that down because there's not a lot of space. So problem number 1, what does it say? 4,000. How would you set that up? You have this little like divide symbol, right? And what? Awesome. Great. What goes on the inside? What goes on the outside? Big number, top number goes in. Denominator on the outside. And then what would you do? What's the order? So just a reminder, last year I had somebody swear that they never learned this. So if you've never learned this, here it is. The order goes divide, multiply, subtract, and then you bring the number down, right? And you kind of keep going until you run out of numbers. So divide, 4 divided by 3 is 1. Multiply, subtract, bring down the 5, right? Divide, multiply, subtract, bring down. Let's do it again. So 15 divided by 3, multiply, 5 times 3 is 15, subtract, bring down the 7. And then we do it again. 7 divided by 3 is 2, 2 times 3 is 6, subtract, bring down the 2, and you keep going. 12 divided by 3 is 4. 4 times 3 is 12. Subtract 0. Now if this is a 0, what does that mean about the 3? Yes, it means it went in evenly, right? This one right here, no, you can just watch on this one, that's fine. But my point in bringing this up is we're going to be doing the exact same thing here in just a minute, but I'm going to be adding x to the 4th, x cubed, x squared, and so on. So I want to remind you how to do it when it's numbers so that the variables aren't quite so painful. Let's do it again, but let's do the next problem. It's 4, what is it? Divide by 3. Now the difference is 1, which means, is it going to go in evenly this time? Yeah, probably not. And I bring this one up just to remind you what we do when we have a remainder. Yeah. So we'll do this quickly. 4 divided by 3 is 1, 3, 1, 5. 5, 15, 0, 7, 2, 6, 1, 3, 4, 12, 1. What do we do with the 1? 1 means, well, if we wanted to make it a decimal, we would put a decimal, add a 0, and we would keep going, right? But I don't want a decimal, I want a fraction. What would I do with it if I wanted a fraction? Maria. And 1 over a third. So this would be a mixed number, right? So today, when we throw in the polynomials, sometimes it'll go in evenly. This means it's a factor. Again, I'm okay if you're just watching right now. If it's a factor, I could rewrite this as 3, oh, that's what it is. Try again. As 3 times 1524, right? This is the same number as this? Yeah. Yes? So I'm calling it the 3 would be a factor because it went evenly. This one is not a factor because I have this remainder right here, right? I want to remind you of one more thing. If I have x cubed and I'm dividing by x, what do I get? X squared. Because 1 from the bottom will cancel from 1 from the top, right? Okay, if I have, say, x to the 6th and I divide by x to the 5th, it would just be x, right? 5 of them would cancel. One last one. If I have 6x to the 4th divided by 2x, what would I get? 4x, right? You okay with all of those? All right, here we go. Are you excited? I'm excited. I'm excited. Here we go. Now, again, please note, write small. Carrie. using long division. Again, I'm going to show you a shortcut on how you can do this much faster. But before I do that, I want to teach you long division. I want to tell you the situation where you can't do the shortcut, and we have to do it this way, and then I'll show you the shortcut. Is that fair? And if you're really good, I'll cut at least one of your problems off your homework so you don't have to do long division 6 times. Maybe only 5. Okay, the difference between 6 and 5 could be like 8 minutes, so you're welcome. Okay, not really. Okay, the x plus 1 goes on the outside, right? Yeah? Inside. First of all, please make sure it is in standard form. That would be really rude to give you a problem that wasn't. So they all should be, but just be sure. Pause, Haley, do you have what you need? Like the now? Okay, sorry. I thought maybe you didn't. Okay. Fantastic. Okay, the first step again. Divide, just like before. Multiply, subtract, bring down, and you keep going until every one of these numbers right here have been dealt with. Okay, when I'm dividing, the first thing I look at is this number right here and that number right there. I completely disregard the 1 for right now. Okay? Just, how about on this one, rather than you writing it down and looking up and looking down, can you just watch? And then we'll start writing things down on part B. Is that fair? I don't want you to miss something. Now, if I'm dividing, what I'm saying is x cubed over x. We just did that. What is x cubed divided by x? I'm going to put my x squared right here. Sorry, no words. Do I know how to put that? Hold on. I'm putting it right there so that all of my x squareds line up in a nice long row. So the entire row, this will all be x squared. Okay. Now, so I've divided, now I multiplied. X squared times x is what? X cubed. But when I'm multiplying, here's what I'm really doing. I'm multiplying by the x and the x plus 1. So I have to do what? Distribute, right? So x squared times x is x cubed. X squared times 1 is x squared. Draw your line. Okay? Again, this one will go a lot slower because I'm kind of getting you used to it. I promise after step 1, I don't expect perfect clarity.
So you don't have to divide the line.
Oh, that's right. I meant to start with this right away. Okay, we're hurrying.
You don't have to divide the line.
Yeah, no. You ignore the one when you're dividing. Just those leading terms. Okay, so divide, multiply, now we subtract. Now when we did our subtraction, we learned, or we remembered, you have to subtract the entire line, right? So we're going to change those signs. And then combine. These two, the first two will always cancel because of the number you put right here. So those will always go away. Combine those, you get 6x squared, bring down the 15. And then you can bring down the 9 if you want, but you don't have to. Again. Thank you. No, thank you. Okay, do this again. So we go back to the divide. So we take this one, and we're dividing this one down. Okay? So it's like saying 6x squared on top, x on bottom. That was cancel, simplify to be what? So plus 6x. Now we multiply. 6x times x, 6x squared, 6x times 1. So I don't ignore the 1 when I do the multiply part, only when I do the division part. Okay? Now we subtract. Yes, always. If they don't, then you mess something up right here. Yeah?
But it's just an easy problem.
Yes. Okay, so combine those, you get 9x. Bring down to plus 9. And you do it again. 9x divided by x. If this helps you to write it out on the side, do it. If not, you don't have to. It's just x, or just strike that. I meant that to be an x. Okay, there we go. That's another, notice on this one, I knew I messed up because I tried to put an x here, and then I had a 6x and an x, and I knew that couldn't be right. So I saw my mistake because I just turned. All right, so 9 times x is 9x. 9 times 1 is 9. Divide, multiply, subtract. Change the sign. That cancels, I get 0. So it means one of two things. It's a factor. I got a 0. So that means this goes into this evenly, right? My answer is x squared plus 6x plus 9. The x squared right here. That one right there. Okay, I'm going to do a lot slower over here then. Is that fair? Okay, now do it with me this time. There's going to be a lot of erasing going on. Is that okay? Because I keep like moving my board. A lot of erasing, sorry. I just need space. I'm glad you did. That's it's not a game. You can't use your brain today. Okay, here we go. What goes on the inside? What goes on the outside? 2x cubed minus 7x squared minus 7x plus 13, right? So far, so good? Okay, here we go. Now I'm only looking at this term and that term, right? Is that okay? The very first step is to divide. Now you don't have to write this part down, but this is what's going on. P.S. I'm recording, so it probably would be beneficial to take part in class on your own time. Hopefully you can hear everything. You'll hear this conversation. Okay, so we're dividing. We've got 2x cubed on top, so that's what I'm dividing, divided by x, right? Now if I were to just simplify that, what do I get? 2 divided by 1 is 2. X cubed divided by x is x squared. This is why we took that day to simplify our exponents. Remember that day in everything else, right? Where we had some on top and some on bottom and things canceled? Ashley? The reason was on the last one, I think it was 9. I wrote it wrong the first time, and it was supposed to be divided by x. So the x's cancel, and we just have the 9. Because it's x cubed. Where are you getting the 8 from? Okay. Hopefully if we kind of go through it a couple times. Oh, because it's the 9 divided by 1 is 9. X divided by x is times 1 is what would be. So it's the x's that are, thank you. Yeah, it's a divide, not a minus. That would be the 8x. Sorry, I couldn't figure out the 8 from over here. Got it. Okay, now we multiply. 2x squared times, sorry. 2x squared times x is what? 2x cubed. 2x squared times the negative 4 is negative 8x squared. Draw your line. Now what? Now we subtract. And when we subtract, then 2 becomes negative. The 8 becomes positive, right? Because you have to change all of the signs. Yeah, because it will change everything behind it. So those go away. Combine those, we get x squared. Bring down the 7x. And we do it again. Because it was negative, so when you subtract, you have to distribute that negative, right? So you change it positive. Yeah. This is a great one. Let's keep going. Okay, x squared divided by x. If it helps you to write it out, do it. X squared divided by x is what? X. Plus x or minus x? Yes. Multiplied. X times x. X squared. X times a negative 4. Negative 4x. When I subtract, I have to change the sign of everything on the second line. You don't change the first line, you change the second line. Now we combine, those first two cancel. The negative 7 and the positive 4 make a minus 3x. And then what? Bring it down to 13. I'm going to do it one more time. Yeah. Okay, so let's divide. Negative 3x divided by x is what? Minus 3. Multiply negative 3 times x is minus 3x. Negative 3 times the negative 4 is a positive 12. Right? When we change the sign, I've got a plus and a minus. The 3x's cancel. Remainder 1. And then what do we do with that remainder 1? It's going to be 1 over what? Minus 4. Ooh. Ooh. All right. Do you see why the kids shut down and said I'm not doing it? Yeah. I'll tell you one thing. 95% of the time we'll be doing the synthetic division the shortcut way. Like this just happens on a very, very small amount of time. Notice between these two, what kind of expressions do I have on the denominator? They're both linear, right? Yeah. If it's not linear, you have to do it this way. If it's linear like that, we can do the shortcut way. Because the degree right here is a 1. So just so you have practice, look down here at part E. See how this one's not linear? You could not solve this problem without doing long division. You would have to do long division. So what I want you to do, this board is a mess. What I want you to do is try part C, all on your own. I don't imagine you'll get much further than like step 2 or 3. So don't feel bad if you don't. But just try it. If there's value in seeing how far you can get. So you start part C, I'm going to take roll. Brady and Katie. We subtract the power, we divide the number. Yeah. Okay, so you see how far you got? All right, here we go. Get myself some space here. Okay, the 2x plus 1 goes on the outside. 6x squared plus 7x plus 2 goes on the inside, right? So far, so good? Okay, call this a victory. Now, we're only looking at which two numbers? The 6x squared and the 2x. Fantastic. 6x squared divided by 2x would be what? 3x. And I'm going to put the 3x here so that they line up. Now, if you don't put it there, it's not wrong. I just like to keep my stuff in order so I'm less likely to make a mistake later. Okay? Now I'm going to multiply. 3x times 2x is 6x squared. Oh, look at that. 3x times 1 is 3x. How many of you got at least that far? I feel really good about this. Okay, now what? Make them the opposite. Those will always cancel if you make a mistake. Add those, we get what? 4x, bring down. So far, so good? Okay, cool. Now, we look at the 4x and the 2x, right? Divide them again. 4x divided by 2x is 2. right? 2 times 2x is 4x. 2 times 1 is 2. Then what?
We change the sign.
Yay! What's that? I'm so proud of you. Yesterday we got to about right here, and they were like, yeah, and that's as far as I know how to do. So this makes me so happy. I'll be honest, long division is not my favorite thing to do in math. But I'm really excited right now. Like, this is a good moment for me. Now, because it was a 0, what? It's a factor. Now, because it's a factor, right here, I'm kind of jumping ahead, but right here it says write p of x, that means polynomial, as factor. Okay, I just want to kind of jump ahead. Here's how I would send this kind of answer. I could rewrite this like this. Doesn't it kind of look like I played the game, but not in a very fun way? Kind of looks like I factored it, right? Yeah, see what I just did? I took what I divided into it, and that's my outcome. If I were to multiply this all out, I would get the 6x squared plus 7x plus 2. If I were to FOIL that. But what's my answer here? 3x plus 2. Okay, cool. Yes, please try part B on your own.
So it should be after the number. It should be oh, I know you're not.
After your third time, do you feel a little bit better about it? I'm not asking if you love it, but do you feel like a little bit better about the process? I hope. Good. And again, we're doing this right now because soon I'm going to have to factor really big polynomials. And this is how I'm going to do it.
At this time, we need the girls' soccer team to immediately be relieved and for to get their bus. They need to make it to their bus within the next 7 minutes. Thanks so much.
Okay, let's try this. 9x squared divided by x is what? 9x. Multiply. 9x times x is 9x squared. 9x times a negative. Now be really careful with your negatives, right? If you miss a negative right here, it will affect everything below it. Yeah, back. So that's how I might. Very careful. So 9x times a minus 1 is a negative 9x, right? Now, because we're subtracting, we change the sign of everything there, so it turns into a plus 9x. Okay, those will cancel. That becomes a negative 12x, brings down the negative 20. Do it again. Negative 12x, divide by the x, minus 12, good. 12 times x, negative 12 times x is a negative 12x. Negative 12 times a negative 1 is a positive 12. When we subtract, change that to a plus, change that to a minus, and you get a negative 32. That's like your remainder. So you probably got a negative off, right? Yeah. Now what do you do with that 32? So minus 32 over x minus 1. That's it. That's it. You say that very loosely here. That's it. Okay, right? Okay, let's do it again. This time part D. Are you okay with this? Can I clear it off? What's different about part E from A, B, C, D? It's wording rather than the symbols. What else? I've got an x to the fourth. Now, first of all, it wants to know, is x to the fourth a factor of yada yada? How do I know if it's a factor? If the remainder is 0, right? In the very end, if the remainder is 0, I know it's a factor. This right here, this just means, oh, I hate when I do that. This just means I'm dealing with a polynomial with the variable of x. Like that, it's nothing fancy. It just means I'm dealing with a polynomial, the variable is x. So let's divide this out. X to the fourth minus 1 into x to the fifth plus 5x to the fourth minus x minus 5. Okay, we're looking at these first two terms. X to the fifth divided x to the fourth. What is that? X. I'll put it right here. Multiply. X times x to the fourth is x to the fifth. X times a negative 1 is a negative x, right? Now what do I do when I subtract? Change it so it's a minus, change it so it's a plus. Now what happens here? This cancels, and this cancels. Yes.
Yeah, that's all.
Why did we skip? It's not that we skipped it. It's that when I multiplied here and here, I didn't get an x to the fourth. So I just kind of, so I lined them up. Let's just backtrack a little bit. There. Now, are you okay with the x part? Or right there? Because x to the fifth divided by x to the fourth is one of the x's, right? So multiply this with this, we get x to the fifth, right? Multiply this with this, we get a negative x. So I didn't intentionally skip it. It's just when I distributed it, I didn't get any fourth degree. Now we subtract. So I change that to a minus and that to a plus. Those will cancel. This has nothing to combine with, so you just have 5x to the fourth. This cancels, and I'm going to bring down that minus 5. Is that all right? And now we do it again. Divide it. 4x to the fourth divided by x to the fourth. Sorry, 5x to the fourth. What is that? Just 5. So I'll put a plus 5 right here. Multiply 5 times x to the fourth is 5x to the fourth. 5 times 1 is negative 5. Subtract. Change the sign. Cancel, cancel, 0. Now the reason that the exponents kind of bounced around a little bit more is because we're missing terms between the fourth degree and the constant, right? That's why it kind of bounced around weird. But let's go back and answer the question. Is it a factor? Yes? If so, write it as a product of two factors. So what did we get as our final answer? And what did we divide into that? So these are your answers. Yes, it's a factor, and because it's a factor, I can rewrite that. No, not at all. Austin? You ready to learn the short way? Yes. Okay, a couple things first though, not long things. If I want to simply determine whether it's a factor, when I say factor, there's another way to say it. If it's a root or if it's a solution, if I have a graph, this is a third degree, so maybe it looks something like that. If it looks something like that, if it's a factor, that means if I were to plug in a number, my outcome would be 0. It's crossing at that 0 line. If it crosses right here at the 0, that means it's a factor, it's a solution, it's a 0, right? Now if I wanted a shortcut, I could divide this out to determine if it's a factor, or if I plugged in a -2, if I plugged into a -2 here, and my output was a 0, that means it crosses right here, right? And then would it be a solution? Would it be a factor? Yes. So if I plug in -2 right here, let's see what I get. -2 cubed. If you're using a graphing calculator, make sure that's in the parentheses. Plus 4 times the -2 squared plus -2 minus 6. Figure out what this number is. If it's a factor, if it's a solution, it should be a 0. Kind of like a remainder. It's actually called the remainder theorem. Is it 0 when you plug it all in?
You always put it equal 0.
Because the reason is I want to know when y is 0, what's going on here. Okay, so you figure this out. What did you get? 0. So determine whether it's a factor. We're going to say yes. That's it. It's a factor. That's it. Yes. Yes. Okay. Oh, wait, hold on. Yes. See, what about this one? What would I plug in here? I'm going to plug in a 3. Good. Set is equal to 0. Plug in a 3. 3 cubed. 7. 36. 3 minus 6. So I don't know what that is, but I know it's not 0, right? I'm going to say this one is what?
Oh, I don't know that.
I did it one time. So I did this. I said 3 cubed. 3, 3, 9.
I was doing
9 times 3. Yeah. I just found the calculator, so I didn't plug it all in. I just did it piece by piece. Oh, please do, yeah. Oh, it's so great. Okay, so 3 parts today. The first part, long division, that we all love. Second part, is it a factor? How would you do that? Plug in that number, see if it's a 0, right? Third part, let's do synthetic division. Okay. This only works, one more time, this only works if it is linear, which means its degree is 1. The number that you're dividing into the other one. Okay, here we go. Makes me excited. Okay, I just want you to watch really quick. The first thing that you do when you're using synthetic division, you want to make sure it's in standard form, and you may want to make sure that all of your terms are accounted for. There's no extra here, right? If there's any missing terms, you will put a 0 in for that missing term. This is what I mean. The second step is look at all of the coefficients. And we are going to list them. The coefficient of this is 1, -3, -5, -25. That's the first step, is just listing the coefficients. And if I have a term that's missing, instead of saying -5, I would put a 0 if it were missing. Okay, first step. The next step is look at what you're dividing by. If it's a factor, what would x have to be here? A 5, because it would be a 0, right? If I plug in 5. I'm going to put that number right here. Now notice, It's always the opposite of that symbol, right? Yeah. Now instead of divide, multiply, subtract, bring down, your pattern is a lot easier. You bring down and then you multiply, add, multiply, add, multiply, add, and so on. Here's what you do, just watch. You always bring down the first number. 1 times 5 is 5. Add those, 2. Multiply, 10. Add, 5. Multiply, 25. Add, 0. Now, a couple things to notice. This right here is a 0, which means, is it a factor? Yes. Cool. The other thing, I divided a cubic by a linear. If I take 1x out of my cubic, how many x's would I have left? 2. So my final answer would be 1x squared plus 2x plus 5. This number right here is always 1 less than that number right there. Final answer, x squared plus 2x plus 5. Okay, Olivia. Come on. The 5 and the negative, these right here. Hold on. I will. So the 1 comes from here. The 3 comes from here. The 5 comes from here. A couple. Good. Yeah. So those 5. Okay, let's do another one. It's better just to do another one. Okay. Corey?
Where did x squared?
It's always 1 less than your initial degree. Because you've got like a 3rd degree, you're dividing a linear out of it, so I'm taking one of the x's out of it, it's always going to be 1 less. Always. So let's do another one.
Wait, but the next one is 2, so you keep going out, it keeps going down.
Yes, it keeps going down from there. Yeah. And then you just go in the increasing order. Let's do another one. No more questions. Okay. First of all, where does the top line up? So I take a 6, a -8, a -2. That's it, right? What number goes right here inside the box? 1. Any questions with that part? Okay. The first number you do what with? Bring it down. Okay, so here's how you get these numbers. You ready? The order is multiply, add, multiply, add. So 6 times 1 is 6. Is that okay? Add those, -2. -2 times 1 is -2. Add those. Nope, no changing signs, just multiply, add, multiply, add. So how do I rewrite my final answer? Well, this was a quadratic. I divided by a linear, so if I'm taking 1 out of my 2, 6x. Final answer, hold on, sorry. 6x minus 2 minus, now first of all, is it a factor? No. So that means my final answer is going to have a little fraction piece right here, right? Just like when we long divided. Long divided, 4 over what? 1. X minus 1. And notice a few things, like yeah, it's going to take some practice, but 1, there's a lot less to write, which means there are fewer places that you're going to make a mistake. The process, this right here, is a lot more simple, so fewer places to make a mistake. Like I said before, 95% of the time we'll do it this way, because it's faster and it's more productive, I guess, I don't know, more accurate. Let's do it again. Okay, you set up this top. You set up the inside. What is it? Good. Try it. Bring down the 1. Okay. I know, I really. Okay, ready? Here we go. Bring it down to 1. 1 times the negative 5 is? Add. Don't let the 0 confuse you. It's okay. Multiply. Multiply those, you get 0. Add. Multiply. Add. Is it a factor? Yes. How would I write that though? This would be 1 less than x cubed, which would be x squared, 0x minus 1. Now I want to write that even better. How do I write that?
X squared plus 0.
Because if it's a 0x, isn't that just 0? That term goes away. X squared minus 1.
Wait, what is that?
We don't have to write any fraction because it's a factor. It goes away.
Sometimes after you bring the exponents down, it goes down 1 from the 0.
Yep.
Every single point.
Every single time. Yep.
It's right on the
No, I'm just starting. No, just starting. So this one though, 2, 14, negative 58. Is there a constant term right here? Is there a constant? There's no just like regular number, right? And then we said above, if there's ever a missing term, we're going to put a 0. So there's a missing term right there. What goes on the outside? Okay, let's make sure we've got this. Bring the 2 down. 2 times the negative 10, negative 20. Add, negative 6. Multiply, 60. Add, 2. Multiply, negative 20. Add.
Why did you put a 0 in there?
Why did I put a 0 on the end? Because I'm missing the constant term that comes right after this one. So anytime you have a missing term, you have to put a 0 in. If this is a 3rd degree, then there will be 4 terms, yes. Yes. Minus 20. There's always. Give me a second.
So, because there's only 1 term right there, so how can you not put another number?
There should be a constant. There should be just a number.
Like,
Let me back up a little bit. Give me a second. I don't know. Pretend like this is something that has to do with our class. If it said this, is there a missing term in that one? Yeah, there is. I've got a cube. Do I have a square? So if I were doing synthetic division for this one, I would say 1. I'm missing my square term. Negative 2, negative 1. It's a 3rd degree, so I should have 4 terms here. You always have the 3rd, the 2nd, the 1st, and then the constant. Okay? Now on the one before, you had like an x cubed minus 2x squared minus 5x, so there wasn't anything right here. So really, it's kind of like plus a 0, or plus a 0, right? And if I were doing synthetic division on this one, 1, negative 2, negative 5, there's no constant term, so I'm going to put a 0 in there. Okay, go back. So how do I write my final answer here? Plus 2 minus, you always need it.
Wait, what did you? Oh, I forgot that the end.
Okay, so we're going to practice our synthetic division 2 more times, but we're going to do it in the way of some story problems, which will be really exciting. Okay, really quick, it's a polynomial. You're a little luck. Hold on, are you all with me? Okay, if the polynomial, I'm not going to read that, expresses the volume in inches of a box, What are the dimensions of the box? Now, how do I find the volume of a box? I know that I've almost lost you, I promise. 2 more problems and then we're done. The volume of a box. Right? I've got a length, I've got a width, and I've got a height, right? We're doing A. Okay? Hold on, stay with me. So I've got this box, right? I've got a height, I've got a width, I've got a length. Now, now we're told the entire volume, right? We're told one of the sides. Yes? We want to figure out the dimensions of the box. We need to figure out what this is and what this is. But you've already told me length times width times height, right? If this is one of them, don't I have to divide it out to find the other two? Oh, you all just stop it. Yes, we're just going to have to divide it out, right? Now, let's try with numbers. If it was, let me think about this for a minute. Let's do it with numbers first. It's gonna, so say this was volume equals 30, and I told you this was 2. Can you figure out this and this? How would we do it? 30 divided by 2 is 15. So this times this has to be 15, right? So what could they be? 3 and 5. So we have to divide it so that we know all of the different dimensions, right? Now technically could it have been 1 and 15 as well? Yeah, well we're not going to do that. I meant for that to be. Okay, so we're going to do the same thing. One of our dimensions is x plus 1. We have to figure out the other two. In order to figure out the other two, what did we do here? So what are we going to do there? Divide. Okay, great, let's do it. Synthetic or long division? I asked, even though I know the answer. What number are we putting on the outside? 1. And again, why are we putting -1? Because that's what's going to make this 0. This comes down. 1 times the -1, -1. Add. Multiply. Now, it told us that this was a factor, right? It told us that it went into it nicely. So if I don't get 0 right here, then I probably messed up somewhere. It told us that it should work perfectly. So -5, add, you get 6, -6. Okay, so what does this mean? Now, does this tell you what the length and the width are? You're going to have to divide that again, right? But how do I know what to divide into it? You don't. Could we play the game? You're killing me. Was that an excited O or a... I hope that that made it onto my recording.
Wait, what did you put that in with the x plus 1?
Okay, let me just point out really quick, my last class was really excited that they could just play the game and they didn't have to do synthetic division again. Children. Okay, what numbers multiply to 6 and add to 5? 3 and 2. Okay, so x, this is a leading coefficient 1, right? X plus what? 2, x plus 3. Now I don't know which one's length, which one's width, but one of my factors, one of my sides is this. The other side is this. The last side is this. Bam. You got it? Say it again. Oh, good question. Shh. Does 1 and 6 work? It works for the multiply, it doesn't work for the add. But if I did -1, now it doesn't work for the multiply. So 1 and 6 works for the 6, but not the 5. If I change it to a -1, now it works for the 5, but not the 6. So it doesn't work. Okay, last one. And I'm really excited about it because y'all groaned like I was pulling off your fingernails on the last problem. Okay, the volume in cubic inches of the decorative box shown, that's a really pretty decorative box, can be expressed as a product of lengths. So you have this big long polynomial again, right? What are the linear expressions that represent the length and the height? Now, does it give you a starting spot this time? So you gotta do the whole thing by yourself. Awesome. It doesn't say X, no. It doesn't say 1%. X right here. Pretend like that was supposed to be widened out. It's not supposed to be there. Okay.
Okay, when am I ever going to use this in real life though?
We'll talk about that later. Look it, there's no X. Hey, stop it. Okay. Okay. Let's try something. You see 4 terms. What do you do when there's 4 terms? Let's group it. Now, grouping it may not work. We may have to try synthetic division. Now, it's going to come a point. There's going to come a point where you have to figure out what goes there. And if you don't know, you just guess. And then if it doesn't work, you guess something else. If that doesn't work, you cry and then guess something else. But for now, can we try grouping it? Let's group it. Because that's something we know how to do, right? On the first group, what goes into x cubed minus 4x squared? X squared. What is left over? X minus 4. Now, if I get x minus 4 again, then we know that the grouping worked and we can continue and we don't have to synthetically divide at all. What goes into the minus 9x and the 36? A what? A minus 9. What are we left with? X minus 4, so it works. They both have an x minus 4. What are we left with? Now, just like this one, I have a quadratic. What do I do after I have the quadratic? Play the game again. This is the quadratic. We can keep going. What 2 numbers multiply to a negative 9 and add to 0? Where did I get what? There's no x term, right? Hold on, pause. Why is there 0? Because there's no x term. There's no middle term, so my middle term is 0. What 2 numbers multiply? Ignore. Ignore. 3, negative 3. So this is negative 3, positive 3, right? Because x is out front. Yes? Okay, so the very first thing we did is we factored out. Now, we could have done it by synthetic division. We did it by grouping this x minus 4. Then we noticed that this has more to factor. So you play the game again. The dimensions of the box. That's all, y'all. Peace out.